Okay, let's go for part 2. So, in the first part, I was introducing this maze generation system, its multi-level nature, and kind of the fatal flaw in its design. Um, just the approach that I used kind of created a system, not exactly an algorithm, but I refer to it as an algorithm because the intent is the same. So sort of not exactly mathematical approach to generating it. There were some really fun parts to this, even if you have this kind of tree branch-like design that eventually gets into such fine little bits. Root design is probably a better term for it. These fine little parts where they're just, a lot of them are just clipped ends and ending points. You will notice we have a lot of big rooms. And that is important, because that's actually one of my favorite bits about this little generator. So, as I said before, the way it works is it generates a hallway to start, but every time it generates a hallway or room, it looks around the perimeter, finds a bunch of possible points to open up, and then continues to generate from those points and continues to spread out and spread out and spread out. The interesting part is how it decides to do that. So, as it's spreading out multiple branches, roughly the same number of jumps. Some of them may go on longer than others, but what happens is at each point, it can decide whether to make a hallway or a room, and when it does that, it can also decide how long the hallway or room is. When doing a hallway, it only has to decide the length. And so basically, when it chooses to generate the hallway, it sees how long it can go forwards before it starts hitting stone, and then within a max and min range for a hallway, it just says, "Hey, pick a number and make it." And then it just creates it, wraps it in stone, except for a few points that are marked as possible expansions. Now, if there's no room to make a hallway or anything from that point, it just goes, "Oh, just seal it off, make it stone, and drop that possible building point." Doing rooms, though, this is the fun part, and part of the reason this is so slow. What it does is it will figure out roughly how much space it has and what the ranges are, and it will generate a list of the possible rooms that it could pick. And it goes from the smallest to the largest. And the way it does this, and this is very important, is so for a 2x2 room at this point here, assuming all this stuff is already here, this wouldn't actually be, but whatever. It'll go, okay, for 2x2 room, it could put the 2x2 room in these 4 squares, or it could put them in these 4 squares. Can't put it anywhere else because it wouldn't be touching the hallway. Then for 3x3, it does the same thing, but it has 3 choices. And it continues doing so for larger and larger rooms until it reaches the maximum capacity. The reason why this is interesting is because early on in the generation, it has lots of room, and this creates a natural bias towards very large rooms. And this is the part that I find very cool. I apologize because this mic is very cheap, and if my voice gets too high, it tends to do very bad things to it. But anyway, what this means is you have a generation process that has this bias towards using rooms that have the most possibilities in the space. And what that amounts to is rooms that are as large as possible without filling up a large percentage of the area. And if there's huge area, then it's just this bias towards very large rooms. And it does this because, again, you only have 2 possibilities for a 2x2 room, only 3 possibilities for 3x3, but you have very many possibilities for an 8x8 and 8x9 and 9x9 and so on and so forth. And so the list is filled with those, and when it picks one room shape at random and uses it, there will be a lot more entries for large rooms. And so it creates this interesting effect where you have a bias towards large rooms and then little tucked in rooms depending on how much space you have left. That was one of the kind of the unforeseen results I liked about this. I tried to create a busting algorithm, as I said before, not algorithm, a busting function where if it sees two rooms that are close together or a hallway pushing in to stone that has space on the other side, it might try and push those through, looking for good circular points. But the only one I can find that's really noticeable is this one, because the generation algorithm actually ignored that, and I tried to get around that. But most of the time, you just see these tiny little loops. And this is more like what I wanted it to be like, where you would have all these little connecting points, but it didn't work. And I don't know why exactly, but I suspect it just has to do with the order that this stuff is created. And so a lot of these things were probably created before there was a lot of room being limited. And even when there wasn't, the for whatever reason, the probability just didn't occur very much. Maybe because of the hallway length being too short or something. I don't know. In the end, this worked really well. There were a couple bugs with zooming in and out with the camera where it would occasionally flub for like half a second, but that isn't even noticeable. The main issue is the design, and this is why it's always useful to plan ahead and think out what your approach is. I do this a lot now with my programming, and I still mess up so much and run into all sorts of situations. So I can't emphasize enough how useful is to plan ahead, and coding is usually the last step, and it's usually the quickest step of programming anything like this. Yes, if there was one other thing I would say is anticipating problems is really useful, especially if you can do something simple. So one of the problems I had was this clicking thing. I'd eventually get to areas where you just couldn't see anything and it would be all blue, and I couldn't find my way back. The coordinate helped with that, and I have it just say which cell it's on. But another thing is, you'll note, is I basically created this little thing where if the cross-section between the area of the map and the area of the camera is too small, it forces the camera to approach the center of the area of the maze area. So that's why you can't leave the maze region, and that's something I fixed really early on. Once all the various algorithms have been executed, what this ends up as is just a big array of data. I don't keep any room objects in here or hallway objects representing these. It's just basically a big block of points with 0 for these undecided entries, like 1 or 2 or whatever for openings and hallways and so on. And that's how everything is flagged. And that isn't very useful for some things, but it's the simplest way to go through and demonstrate the data. So I kind of like how that went. If I did this again, I would have probably had an extra set of data in parallel to that, marking stuff like this. If you make a game, you do not need anything this complicated. You don't need a maze like this, unless it is actually just like a marble in a maze type thing, and you can see with this level of view how you're kind of going around it. Even then, it's much too big, it's much too deep, but it was a fun exercise. It was really nice to show people, and people liked it a lot because of just its simplicity. And because it was simple, there were fewer parts where it could fail, and that's always important. I'm running out of time here, so I'll just leave it at that, and I hope this was interesting.